Good afternoon, everyone. This is Pouya Banibayat of Midas. Today we have the training for curved steel I-girder bridges. So before I start the session, I want to just ensure that you guys can clearly hear me. So I appreciate if you can raise your hand and show me that you can hear. Then I can start the session. All right, thank you so much. Okay, still more attendees are joining us, but that's okay. I start the session, and because we have the recording, I will be uploaded on our website, goodengineers.com, and later on, everyone has access to the both presentation and tutorial, as well as the video file, video recording. So if you guys attended the first two courses of e-learning session for this month, we had Dr. Diana Nevling talking about the effect of these steel curved bridges during the construction and the construction sequences and the effect of them on the stress, additional stress, displacement, and other effects. Then last week I had a session as a follow-up and then explaining the whatever is required to be considered for this type of bridges. So what code asks us to consider for the curved and also for skewed bridges. We discussed about the construction stage analysis. We discussed about the moving load analysis, and also we discussed about different type of finite element modeling and how to use the software for those types. So today, as a third session of this e-learning course, I'm going to open up the Midas Civil for you and show you what are the options available for an engineer in Midas Civil to model such a bridge. So for today, I prepared a two-span bridge and modeling in three ways, and you guys can compare with all these three and then see which one will be more suitable to your type of work and then whatever you are looking for. Okay. So the tutorial that I prepared for you has all the steps, so I'm not going to show you the steps on the presentation, but I just show them during the modeling. But this will be available for you. You can practice it later on your own. So the material and section will be defined. Geometry of the nodes and the curves will be defined. Boundary conditions, loadings will be applied, and also we apply the live load. So I show you how to define the traffic line lanes, and also in case of we have the plate element, defining how to define the traffic surface lanes, and then run the analysis and then get the result. So let me just show you the bridge that I prepared for you. As you can see, it's a two-span bridge, curved, and we have three main girders with a distance of 10 feet from each other, and I'm using such a girder with a total height of 6 feet and the width of the flanges of 1.5 feet. The total height of the pier is 32 feet, and then we have the concrete slab of 8 inches. So as I mentioned, today I'm going to create this bridge with three different methods of modeling. So as we discussed last week, there are a couple of ways to create such a model. It completely depends on what you want from your analysis and what type of output are you looking for. So the first and simplest way is to model the entire structure, the I-girder with the concrete topping as a single beam, and then use the composite section option in Midas Civil, which is pretty cool and helpful, and model the bridge itself, then apply the loads, and then get the result. This is a very common way, pretty easy and straightforward. You can quickly do that. Another way is you can model the girders with the beam element, as you can see in this model. The girders are modeled with the beam element, so it's a single line element. Then it's covered by the plate elements to represent the concrete topping. And then the third one, we use the plate element to model also the web of the main girders, and model the concrete with also plate. So the third method has like more of the plate elements, and that will be more beneficial when you're gonna study the local buckling of webs, or you wanna see the other effects which you cannot see them in a single linear beams. All right, so let me open the software and show them. Anyway, these are the materials that I have, but as I said, I'm going to open the software and then show them one by one. The sections that I'm selecting, the composite section, then the bracing, and then the pier, and this will be the web thickness that I'm going to use. All right. So these are the final model. I will show them later on, and then we'll compare. I use those models for showing the result to just save some time for the analysis, because each one takes like about 30 to 40 seconds to finish the analysis, so we can save that time and do the modeling instead. All right, so we open Midas Civil. So for whom are not familiar with the software, this is a main graphical interface, a user interface of Midas Civil. When we have the main menu in top, and we call this ribbon menu also. You have large icons to easily find whatever you are looking for, and as you can see, a couple of the icons are grouped under a certain tab, so it just makes it so easier for the user to find what he or she is looking for. So today we'll be using all these, some of these tabs, and then you understand, you will learn where to find those options. And under the tree menu in the left side, we will, for now you see that it's completely blank, nothing is there, but as we go, we'll model the nodes, elements, sections, materials, boundaries, everything will be listed here, and then you can quickly see whatever is inside, in your model. Okay, so I'm going to start the modeling. So first of all, I go to the top view and then start creating a node. So there are options for you to create such a curve. Like for example, you can use the arch option, arch wizard, but I don't want to do that. I want to just start from scratch, everything from zero, just showing you how easy it is to, even without using the wizard, how easy it is to create the model. All right, so we go into the node and element, and then create node. My geometry is, if you remember, we had the total, the length of that, the chord is 200 feet. So let me just set it up to the feet and keeps. Okay, so the first node will be 0, 0. Apply. Then I have a 200, 0, and 0. And then I have 100, and then 30 in the y direction, and 0. Okay, so these are the three nodes that I create. So now what I do, just select all of them. So by clicking these, select all of them will be created. So now I can use the transfer and then copy them 10 feet. If you remember, the distance between center to center of the girders are 10 feet. So I just 10 feet going upward, selecting the previous 10 feet going downward, -10. So now I'm just modeling the bridge using the composite section, and everything will be just the beam elements. We are not using any plate element in the first model. All right, so these three are done. Now I know that if you go back to the model, I have this angle here, this kind of skew, so it's about 30 degrees. So I'm gonna rotate the nodes in a 30 degrees. So I just select these three and then go into the rotate, and about the z-axis, rotation 30 because it's counterclockwise, so it will be positive. Selecting the first point and apply. I want to select move and apply. The same thing for the other end, but that time will be negative 30 degree. And then the point of rotation will be that point and apply. All right, you see that it's created. Close. Now I want to create the curves. Okay, so you see how easy it is to create the curves when you have only 3 nodes, 3 points. So we go to the node and element, and then under the element we can create the element on curve. Click on that. So you have a couple of options: arc by 3 points, arc by center, and 2 points. You can go with the circle, you can go with the ellipse, but for now I'm using a arc by 3 points. All right, so we have not defined any section yet. You see this is the section material, and here is the section. Neither one are defined. We can define them right away by clicking on this and then add, for example, using the steel, ASTM, and A53. Okay. And for the section, we can simply define it right now, or we can define them later. That's fine. So I just defined the material now, just show you how to do it. And then for the section, let me just do it later on, and then add it to the structure. So you see, either way is possible. So number of segment will be 40. I want to divide this into 40 pieces. So I start from here, selecting the point 1, point 2, and point 3. You see, automatically divides into 40 equal points. Sorry, elements. This and this, and this in the same manner. 1, 2, and 3. All right. So my girders are created, but as you can see, there is no sections assigned to them, so we are just seeing them as a one single line. Please just look at the work tab under the tree menu. You see that we created nodes, elements, material properties, and section. All of them are listed here. As you can see, the section is in red. It means it has not been defined yet. So let's go ahead and define the section. So for define section, you can just either click on that and go to the properties and add a section. So for that option, I'm using a composite section. And there is also one option. If you want to define the section, that's fine. You can go ahead and define the section in any new model file that you have. If you don't, you can, if you don't have the, don't want to model that, and previously you created the model, you can simply import it. For example, you can go to the properties, sections, and here's the option, import. So I can just import it from the previous model that I have. But let me just define it now, so you get idea how to get it done. So we go to the composite section, because you remember so that in the first model we are going to use a composite section. So my girders, the dimension are 6 foot total height. I mean the height of the web. And thickness of the web is 0.5, and then the width is 1.5. is 0.2, 0.15, 1.5, and finally 0.2. So these are the thickness of the web, the main girder. Now we have to define the concrete deck as well. So the total width will be 10, and then the thickness is 0.67 feet. And total slab width 10 and 1. Okay, so we just name it as a girder, or let me call it composite girder, because later on we can use different options. So now when you have a steel and a concrete, so definitely the software should, I mean, we have to calculate the equivalent the sections, and then for finding those you know, location of centroid, and then all those sectional properties. So for that reason, software giving you this box here for the material. So if you click on that, it gives you an option to select the material type. So I'm just selecting ASTM. Oh. Okay, that's okay. Let me just select the concrete material from ASTM. We select the C4000 for the concrete deck, and then for the section, we are using a A53. Is exactly the same material that I use for steel material. Okay, and you see that the modular ratio and the density ratio are calculated automatically. And there is one more option which I'm gonna show it to you later on, is change offset. I will show it to you later on, then you feel it better. So say OK, and you see automatically these sections are assigned to the element itself, and then the red color of this section turns to black. All right, so this is my section, and as you can see, it has also the composite part or the concrete. So the section carries the sectional properties of the composite section, which we can define in the construction stages. We can define it for the software that when to consider only the girder itself for the sectional property, and when to select consider the composite section. All right. Okay, let me just show you one more thing. Here now we have to connect the girders to each other, because in a real life we have the main girders, and then on top of that we have concrete, correct? So the concrete does two main jobs for us. One is increasing the stiffness of the girders by making a composite section. So definitely the moment of inertia increases and all. Another thing is makes the girders work together. So technically the transverse stiffness is also increasing. So as of now, if I turn this off or not seeing the 3D view, you see that there are three girders which are working completely separately, and there is no connection between them. Therefore, we have to make the connection between those by some dummy beams. So I could generate some dummy beams. Let me go to the property sections and create dummy beams. All right. I can select the type be rectangular, because it has to be similar to the concrete. So I call it dummy. User defined, and then the height is 0.67, exactly the same height as we defined for the deck thickness, and then the length of that will be 5 feet. Okay, close. Still is in a blue, so I just go ahead and define these, create these sections, elements. So create element from one node to another. So before that I have to select the dummy beams, and then the material, it has to be concrete. So I just add one more option here. So it will be concrete, and from the ASTM-RC I select the C4000 to have exactly the same stiffness as a deck. But here's the thing, we are using a dummy element, which means in a real life we are not seeing those, and we are just using it for the sake of modeling to create to make these transverse connections and ensure the girders are working together. So we are just interested in the stiffness, not the self-weight itself. Okay, so somehow we have to change the self-weight and make it as a 0. So I select none, and then turn the self-weight density to 0. Okay, so now I'm ready to make these connection. So creating this, and as you can see, all of these will be done pretty quickly. So I'm just doing them one by one because this is a curved, and we can't extrude them. But we have the, if we have the straight bridge, that's very easy. You can just select entire the nodes in the bottom and then use the option extrude. So it's a kind of extrude, or creating a beam element or line element from the bottom nodes that you selected. So that's pretty simple and user friendly. All right, we're almost there. Just consider that the dummy beams that I'm applying here, they are in the transverse direction, which means they have nothing to do with the increasing the stiffness or longitudinal stiffness. So we are completely safe, and we are not adding anything to increasing the stiffness of the structure. Okay, but let's just take a closer look at this. It doesn't look really nice as of now, because the dummy beams are placed in the random location in the center of the section. But in the real life, these dummy beams or this concrete are placed in the top of the girder. So somehow I have to push this upward. How to do that? In some software, you have the option for, you can push it upward, make these dummy beams in the top of the girder, and then connect them with the rigid links, which is additional work. We don't do that in Midas Civil. In Midas Civil, there's an option automatically created in this section, where you come to the defining the section. You can use the change offset, and for example, select the center top. Okay, I'm selecting the center top, which means it goes to the top of the section. But here, I want to place it in the top of the girder, not top of the deck. Therefore, I just go a little bit down to the 0.67 from the extreme fiber display, and OK, and OK. So as you see, everything just shifted up, and the centroid of the section shifted up, and then you see that the concrete is placed here. But the concrete is still a little off. As you can see, this concrete is not exactly located on the top of the girder. So let's change that one too. Go into the property of deck. For this one, I'm placing it at the center bottom. OK, and OK. So it just shifted up. Everything is in a real shape that I'm looking for. OK, so this is my main model. All right, so far so good. Now we have a couple more options to do. First of all, we have to define the those cross beams or X braces. Then we have to define the pier cap, and then the pier itself. By the way, I'm just doing the section a little maybe faster than what I'm supposed to do, but this is I'm doing this because I want to show all three models to you, so you get a better idea. This recording will be uploaded on our website, so you have access to that. You can go through that later on as well for more learning. And by the way, if you had any questions, please just feel free to send them through the chat option. Okay, so let's go back to the modeling the cross beams, cross frames. So by the way, everything that you are modeling is shown up here. Okay, and you can simply turn them on. Dummy beams, you can just turn them off, and then you are seeing only the girders. All right, if I go to the top view, I want to select a couple of nodes, because see what we have. If I turn this off, in the real model, I have only the one-dimensional elements, which means I cannot really create the cross beams unless I define additional nodes in the Z direction, where it give me the like a third dimension, and then I can define those X braces or dummy or the cross frames. There is one question, just let me quickly answer that. They asked if I can enter the horizontal and vertical curve data. Yes, it's possible. If you have super elevation, you can simply do that. It's done all through the geometry. You can simply change the location of the nodes and everything will be adjusted for you automatically. In this model, I'm not going to show it to you, but later on we can discuss more and I can show you the model, how it's done. Okay, so this is the reason I'm going to, for creating those expresses, I need to define additional nodes on the bottom of these things. Okay, so here's one, here's one. All right, so these are the nodes that I'm going to create, copy them in a third direction. Then I can define those cross beams. All right, I selected them all and just go into the node and then translate again, copy. This time I'm going to go to in the Z direction because here you can see that X and Y. In the Z direction, we go negative 6.4, which is total height of the girder, and say apply. So you see these are just created for me easily. All right. So let me just go here. I can turn off these guys. Just let me just select them. I don't need to turn them off. But anyway, now what can I do? I can just simply go through them one by one and create those expresses. So let's work on the right part first. So I activate this guy. All right. So I can create a section for that purpose. We call it bracing. Go into the property and then the section. Add one section. Well, let me. You know what? I want to just import all the sections from the other model that they have. All right, so all the sections that I have are selected here. So I don't want the girder, I don't want the dummy beams anymore, but I want the rest of them. New node in, node number starts from 3, and okay. So rest of them are came to this model. So I just grabbed them from the other model. So that just makes my life easier. I can go to here, create elements, select the material would be bracing. The section bracing and the material, so I can just create from here to here and also from here to here. The same thing goes on and on. Okay, so it will be the same way that we can go through these, and we create this one in the bottom as well. Let me just create this from here to here and from here to here. All right, so if I turn this on in the 3D view, you see that the cross beams are created between top and bottom flange. So although we use the beam element, we are able to create this. I don't model the rest of them, but that will be exactly the same way. So we can just simply select the nodes and then create these cross beams. All right, so let me activate the entire structure and turn off these dummy beams. So let's see, imagine that we got all of these. Now what I'm trying to do, I want to go to the define these pier cap and then the pier for you. Okay, so I want to place the pier cap underneath these guys. So I just activate this part of the structure and say activate. So what I do, I need to create additional nodes to the bottom to place my bearings, and also copy the copy them for the pier cap. Exactly doing the same way. Let me just select these guys, all these three, and going to the transfer nodes, going downward half a feet, 0.5 in a negative direction, and apply. So there's something here. So we can just create the bearings between these guys, and I need to make additional nodes. So I just select them, these, and go in the X direction as a negative, no, as a positive, 4, 0, and 0. So we go in the Y direction, so it's gonna be 0, 4, and 0. Apply. The same thing, we select the other element, other node in the right side, and this time I go in the negative direction because it's the global Z direction, goes to that way. All right. So what can I do now? I can create the element between these guys from here to here, from here to here, here to here, and here to here. So you see that the wrong section is assigned to this part, because this composite section cannot be used for this purpose. So how can I change that? Let me just divide these guys also. All right, divide into two parts. All right, so how should I change them? That's pretty easy. We can just simply select them and drag the section that I'm going to use. For example, here for the middle part, I'm going to use the pier. It automatically changes. For the left part, I'm using the pier left, and for the pier right, I'm using a pier right. All right, so that doesn't look good. I can simply switch the local direction of this element. All right, and as you can see, this is the shape that we have, but this is not what we are looking for. When we say tapered section, it means it has a smooth curve. So how to fix that? We go to the properties, and then you see the tapered group. Just click on that. We select the tapered left, and the list of element, I just select these two guys and just say add. It will be automatically fixed, and so that tempered right, and again add, it's also fixed. So you see how quickly we can get the tapered section done. All right, so I need additional node bottom of these bottom of these pier cap, because my column or my pier starts right from this point. So the total, if I go to the pier center, go to the properties, you see that the total height is 6 feet. So simply I can just select this node, and as we done previously, translate, go down in -6 feet, number of time 1 time, and all. That's okay. All right. Now I want to create the pier. So this is one of those things that I told you. Creating the pier, creating the element is easy using the extrude option. So let me select this, and then going to the extrude from node to line, selecting the material as a concrete, and then the here, we go down negative 6 for each segment, and I want to repeat this 4 times and apply. It's created. And then how to connect these two nodes, because they have to work together, we can use a elastic links of rigid type. Alright, so simply I can connect these to this, and it means that these two nodes are working exactly the same together. That's the point. Okay, so our model is almost ready, and we need to just apply the boundary condition. So let me just show you. Of course, this model is not ready for running analysis, but I can open another model which has exactly the same configuration, and then we can run the analysis on that one, because for the saving time, I didn't complete the model everything. So let's go to the modeling the supports. Just for now, let's imagine that we're going to apply the like a normal support, but you can apply the springs, you can apply the linear and nonlinear, you can apply the links, and you now apply those bearings, whatever is required for your real project. You can simply do that. As I define support, so here we have 6 degrees of freedom, translational and then rotational. Let me for this point just fix them all and apply. And for these guys, let me just select LRX and then apply. And then for the other end, I just apply DZ and DY. Should be enough. Okay, so we also apply the support. We can define the moving load as well, and then run the analysis. Okay, so this is one model I want to show you. I want to show you how to create. So this was the part 1. If you're going to go to the part 2 of the modeling, which means here, if you check this status here, under the element we have only beam, which means entire the modeling done only with the beam elements. Now, what if you guys want to use a plate element to cover the top of this girder to represent the concrete? So that way, let me just quickly change the model for you. We are just working on the same model, but I want to just change something for you guys. First of all, let's change the sections that we used. If you want to cover this with the concrete, let me select that. If I want to cover this with the concrete or the plate element, then we don't need these dummy beams anymore. So the first step is to get rid of these dummy beams. Dummy beams, double click on them, come here, and then delete. Alright, so these are gone. Now another thing is, when we are modeling the plate element, then we don't need also use the composite section as well. What to do? We have to define a new section. So we're going to the properties section. So just if you guys are not following, I'm trying to create the do the following method. Just let me show you again. Just refresh your memory. The first one we just completed. We just finished that. Now I'm going to the next one, which means I'm using a beam element for the girders and using a plate element for the concrete topping. So I'm using the same model, just expanding it to the next level. Alright, just let's quickly do that. I call it girder this time. And we go with the user define. Total height will be 6.4. B1 is 1.5. T1 is T-web is 0.15. TF 0.2. 1.5, 0.2. I know. Okay, this is created. Close. I just select these entire the composite girder and then replace them with the girder. Just drag it and drop it here. It's done. All right. And as you can see, the centroid is in the center. I want to just switch this again. Go to the girder property, change offset, and select the center top. Done. And it's placed up there. Okay. So so far so good. we need to now create the concrete topping. So for concrete topping, just one quick trick I want to show you here. So let me go to the side view and select only the beams. And activate them. Right, that's okay. So now what I want to do, I need an addition, because we have overhangs, I need additional points right outside and inside of this curve to create the, concrete. So what I do, I just use the same geometry in the beginning, like what I did in the beginning. So I use the 0, 0, but instead I know that it's going to be 10, 15 inches, 15 feet above the point of origin, or away from the center of the center girder. So what I do, X will be 0, Y will be 15, and Z will be 0. This is my first point, shows up here. Then the next point will be 200, 15, and 0. Third point will be 100, and 45 and 0, apply. And the same thing for the other end, so it goes a negative, so we go again with the 0, so negative 15, negative 15, 0, and 0. Sorry, 0, negative 15, and 0. Then 200, negative 15 and 0. And then a negative 15 plus 30 will be positive 15. And then this will be 100. And okay. All right, I got these 3 points. So now, if you remember, we rotated those nodes. So I just select these and these, and go to the rotate node, selecting the about Z, and the rotation degree will be 30 degree, point about this point, and select move and apply. All right, placed here is completely correct. Now we go selecting the other guy. This time will be negative 30, and then the point of rotation will be this point, and apply. All right, that's good. And these guys are in the right location. So now I do exactly the same thing as I did. So let me just quickly do that. Doesn't matter what elements are you selecting as of now. We can go with the like a bracing to be smaller, and the number of the segments will be 40. Selecting from here to here to here, and again here to here, from here to here to here. All right, these are done. So now what can I do? I need just the nodes. Okay, so I will show you why did I do that, because I'm going to mesh this side, and I need additional nodes in outer side. So I need to just select these guys in the middle. So you know, when you have like a curved geometry, that will be hard to select the, now selecting by this option, because if you want to select them, there are additional elements will be selected for you. This is a normal way to selecting things, but Midas will give you this option, polygon, where you can just you know, define the polygon around the elements, and whatever is inside that polygon will be selected for any action that you want to do. Alright, I select these, I just inactivate these guys, and what I do, I just select the entire thing and remove the nodes, and I just delete entire the elements. Okay, the elements are gone, and what I have here is if I activate everything, I have certain nodes and also the other nodes that I had. So once again, I need to activate these guys. Going to top view. Okay, this is what I have. Now I have girders, 3 girders here, and I wanna model a concrete topping for this model. For this reason, we go to the auto mesh, and then selecting from the nodes, and you can select the quadrilateral or the combination with the triangle and quadrilateral. So just stay here. You can define a plate element if you don't have. So it seems that we don't have anything. So I can just import it again, similar to what I did the other time. So I don't have plate elements here. Import. I can go back and select it from here. Open. This is the plate girder that I defined with the 0.67 thickness. All right, so staying here, I have to select one by one of these nodes. So you need just to define an enclosed area for this mesh, and then the software, based on the coordinate of the node and the arrangement that you have, defines the best mesh available for that area. If you want to define the mesh the inner domain, you can also ask it to do that, but I don't recommend that because it gives you some random shapes that may not be very interesting for you. So you can go just with the general approach. All right, we are almost there. Okay, so we call the name as a deck and apply. All right, as you can see, the mesh is created for us, and now we have the concrete deck on top of my girders. So now we have the beam elements here to represent our girder, and then we have the plate element to represent our deck. So there is just one other point important here. You remember I talked about that offset option. The offset option is helpful here because for the plate I push the node to the bottom, so it's just exactly placing right in the bottom of the slab, and then for the girder I pushed it upward, so they are sharing this node, so you don't need to define any additional rigid links to make this connection. Okay. All right, so that's another way to create the model. So for now, we got the different model. Now let's talk about this option. We model the first and the second. Let me just open it again. So we modeled the first model. We created the second model as well. And now we can talk about the creating the plate element with the beams. So if you have such a curved geometry, the one of the easiest way is just to use the extrude option. So what I do, I just inactivate the plate elements or the concrete deck. Okay, main girders, let's activate them all. All right, so this is my main girder. Now just imagine that I want to study the buckling of or seeing the warping effects of this girder, the web. As of now, if I turn this off, you see that this is only one beam. You can apply the buckling analysis on this beam, but in this case you are seeing just the global buckling of the structure, but you are not seeing the local buckling of the web or flanges. So to make that happen, I can create the my web also with the plate element. Let's do that one as well, and then we can switch to the next part, and I can model the moving load for you, and you see how it's done if we get enough time. All right, so the third part, let me just quickly do that. So if you want to create this, go to the property, define new sections. I want to define add. I call it flange. All right, and then selecting by the user define the thickness. Height was 0.2, and then the web was 1.5. Okay, and then we define another thickness. This time I'm calling it a web, and then the thickness going to be 0.15. Okay. 0.15. Okay, and now what happens? I want to just switch the entire the girders. Let me select all, and then apply only the flange. So what I'm going to do, having the flange model as a beam, the web model as a plate, and then the bottom flange also create as a beam. Again, I'm selecting them all, and going to the node and element and extrude again. This time I'm going to extrude a line and then create a planar or the plate. Alright, so I'm selecting this guy and steel material and going downward -2 for each segment, and then repeat that 3 times and apply. So you see that my web is created as a plate element, and then I have my flange as a beam element. All right. So what can I do? I can just model the same flanges in the bottom part. So let me just quickly do that. Flange, and then go into the node and element, and then copy the elements, and then translate. All right. And equal distance from here to here. So you don't need to know exactly the dimensions, and apply. All right. All right. So this one is done also. Now you can see that this is more sophisticated model because what we have here, let me turn off the nodes, and now we have the webs model as a plate element, the concrete is modeled as a plate element, and the flanges are modeled as a beam, and those X braces or the cross frames are modeled as a beams. So in this model, it might take more time to run the analysis, but you are safe, and then you can analyze it more accurately. So let me just do one more thing for you, just modeling the moving load and all moving loads for you, and then that will be the end of the session. All right, so let me see if we have any beam elements here. No, it's all plate element. That's fine. Check. And if we have such a curve, that's important to define the moving lane exactly through this curve. So how to do that? Let's go to the load, and then moving load, selecting the H2 LRFD, for example, for this model, and then traffic surface lane. When you have the plate element, we go with the traffic surface lane. So I call it lane 1, and then the lane width will be 12 feet. Offset will be -6. Start skew, we keep it as a 0, and then I'm selecting as a picking. So I'm going to pick the one by one of these nodes, and then it will be generated based on the offset from these points. You can also follow another method, like selecting the numbers and that way you have to select all the bottom nodes, and then you see the name of the number of the nodes. Then you can just copy paste them there, and that's also one possibility. So I just create this for you. You get some idea, and then we finish the session. But as I said, if you guys have any questions regarding such a models, please let me know, and we can discuss more in detail. Okay, we are almost there. And when you have like a beam elements, that will be way easier. You just select entirely beam in one shot, and everything will be created for you pretty quickly. All right, 3 more nodes, and we are done. Okay, and say apply. We get the traffic line lane created here, as you can see. So this will be all this area. So I just defined the 12 feet width of the this lane, and then I gave the eccentricity of 6. So it's just here is the center of this lane. So you can simply define the same lane in the other side with any eccentricity that you guys are interested in. Then we have to define the self weight for this, and you know, the rest of the story for such elements. So let me unselect these. Yeah, and this again, you have to apply those boundaries which we defined previously. Those expresses should be applied, and when you, that's the important point, when you do the beam plate element like this one, so you don't need to define additional node in the bottom, because, for example, if I want to show you this corner, this corner right here, what I have, if I turn on the node number, you see that there is one node up here, and there is one node up here, one node down here. So I really don't need any additional nodes to be defined there to create those expresses. Those additional nodes are only used when you are modeling it with the composite section, because this is a one-dimensional element, and then you will need additional node to be able to go into the space or three-dimensional. Okay, so that's all I want to share for today, and I hope that you guys learned the different methods of modeling such a analysis, such a models, steel curved bridges, and definitely all those what we discussed in the last session about the warping effect, about the torsional effects, all of them could be seen in these models. Again, depends on what's your need from the, what you're looking for from the output. One of these models could be the best for you. All right, thank you again, and have a great evening.